the fair.
And we have another member, Andrew, but he's not currently present because he's sick. And so basically, we built the automated pet feeder. Yeah. So a little background of our project is that we are all dog owners and we're away from our house for long periods of time working on projects like these. So we don't have anyone to take care of our pets, like feed them. So we all agreed to make a automated pet feeder with a water system. Yeah, so basically we have 3 tags that relate to 3 sizes of pets, if we have multiple pets, and the size depends on how much the amount of food it dispenses. And so we used sensors, and we couldn't use the Pico, but we used the
Is it a Jetson Nano?
Jetson Nano, yeah.
Yeah, so we used the Jetson Nano because originally we used just a Raspberry Pi 3, and that was working fine. I ran into some issues with it, so it was crunch time, so I had to swap it out real quick to the Nano, which works just as fine. The reason we used it instead of the Pico is because of the CircuitPython libraries for the RFID. The Pico wasn't able to handle it. So as it's running right now, the dogs are only allowed to eat every 8 or so hours, but right now it's 20 seconds or so. So they're all enabled to eat. So when I scan one of the tags, the dispenser is going to start spinning, and then wait a little bit and the crank will start spinning and put out the drawer. The timing's a little off, so it doesn't come out all the way, but so this is a medium-sized dog, and then it waits a little bit and would dispense the food. And now, since he's already eaten, if I scan this again, he's not going to be able to eat. So it prints on the OLED that this dog's already eaten, and it won't work. And then after time, it'll enable again. And then, so if you look at the small dog and I scan this, it only spins for a little bit, so he only gets a little bit amount of food. And then for the water system, we used a flow sensor, which uses a Hall effect sensor. I had some issues actually getting it working because the Nano doesn't have internal pull-ups. So I had to make an external pull-up, and that didn't work, so I tried interfacing with the MOSFET. And I hooked it up to an oscilloscope and saw the 3.3 and 0 volt change, but I couldn't interface it with code. So I manually calculated the flow and basically hooked up the solenoid valves so that it would open and close to recycle the water system. So there's one solenoid valve at the top reservoir that would fill up the water bowl, and under the water bowl there's another solenoid valve that would drain out all the water. So every 8 hours or so it recycles the water.
Great, so what did you guys learn?
That troubleshooting takes most of the time. Interfacing state machine is another thing. I didn't use an eventer. We didn't use an eventer like we did in the lab. Kind of just put everything into one file using a bunch of if-else statements and then returning values based on those.
Yeah, and we learned that certain microcontrollers don't really work with certain sensor libraries, so that was interesting. And so this is also like our 154 project with the rocker crank mechanism. And so basically, like, first we built this whole thing, like the design for 154, and then we had to like integrate the electronics after. So that was a big challenge, like, because we designed it first, and then we had to figure out how to, like, you know, put all the like the 2 parts of the project together. So yeah, that was interesting to learn.
All right.
Yeah.
Document it all in your report. Let me take a picture of you guys. This your unit here. Ready? 1, 2, 3, go. Got it. All right. Thank you very much. Cool. All right.